let's do this. All right, so today the stream is titled Pointer Pointer Print. Thought about putting an asterisk, but I thought maybe that would be too much. All right, so whether you know it or not, every time a C program is called, or most every time, it is actually passed in a pointer pointer. So a pointer to an array of pointers is what's happening. So we can print those out. That's pretty simple. So there are actually two that are typically defined in most any C program. So I'm just commenting here. All right. So I think we will start at the beginning. So I'm going to comment out all this old code that we had. So let's think about how we want to do this. So typically, here are the two. Int arg c char pointer pointer arg v. I wonder if this will let me do u8. Not sure if it will like that. Make it a tad bigger. Make. It does nothing. Perfect. All right. So what I'd like to be able to do is to be able to print off some of these values in the sort of bytes that they have. Let's start off with the basic, and then we'll see if we get to that. Okay, char pointer pointer, and it's a uint 8 underscore t. All right. So the way these work is you go until they are null. So you can put that in a loop. Current. So let's say char pointer uint 8 equals. Well, let's check. I guess we need to check that. So you'd say while the value of value is not equal to null, we're going to do our thing. So I think that seems legit. Up here, we're going to call it with, and so I guess I didn't explain. So argv is the arguments you pass to your program. So let's just do a save. I think this will make. So if I type ABC, the way argv works in normal Linux or a normal shell is the very first argument. So arg0 is the name of the program. And then you've got each of these passed as there's a pointer to an array. This array has one thing. This one has one. This one has one. If I gave this one 2, that one would have 2 items in it. All right. So while the first pointer is not equal to null, we'll go ahead and grab a current pointer, and then we can just print this. Print f the value at, and I'm going to keep track of an index, int I equals 0, I plus equal 1, value at %d, say index, I'll put a bracket around it, is %s. Right, so these are strings. So it should be able to pass in I and current into there. So then we should be able to char pointer print. I might have to either do a forward declaration, or I might have to move this up to the top. Argv. I'm going to move it up to the top just because that's easier. And then I'll just call it at the top so I don't have to scroll down. Okay, make. All right, and then I forgot to update current, or sorry, value plus equal 1. Now, when it does this plus equal 1, it knows this is a pointer to an array of pointers. So it should go to the next one. And I also see we don't have a /n in here. All right, so let's make. There we go. So we can see that it went through. So the number of things in here, the arguments, is actually argc. So argc tells us actually how long that array is. So actually, if we pass it in, we would know. Now, we don't know that on the environment. So the environment is the second thing that's passed in. We just know that's a pointer to an array of pointers, and we don't know the size. So this will actually work for that. So let's actually print that. Hello, child.
Did you know that we broke a glass?
Yes.
Okay.
All right. Goodbye. Okay. The args are as follows. And then oh, I always forget I need new lines. This is not Python. /n. Okay. And we are going to print off env. All right, clear. Don't make. All right, I'm going to make this bigger because there's a lot of environment variables. So the environment variables are set up by Linux and the shell to give you some additional runtime info or configuration. All right, so it tells you a bunch of things that might be interesting for some programs. Not all programs need them, but some of them might. You know, we can look in here and see, well, what is our shell? Now, the way these are set up, it is the variable, and then you've got an equal sign, and then whatever the rest of the line is the value. So you can see ls colors. So that's the colors when you do an ls, is quite long. But each one of these is a line, and then if you have something that has sort of multiple entries in it, then they typically will use a delimiter. So if we look at path, let me just Control F, path. All right, so the way the path works is you have path equals, and then we have a series of, oh gosh, VS Code has a giant one, a series of strings, that do not have colons in them that are separated, and the order is where it's going to search. So when you type some command, so when I type some commands are built into the shell like ls and echo. But if you go and execute some other command, for example, htop is one that I use a lot. So if you run that, it has to know where that's installed. So if I type htop, looks like I have it installed. If I want to know where in the path it is, I can say which htop, and it'll tell me that's in user bin. And if you look in the path, you're going to see user bin right there. Right? So the shell looks at the path and says, okay, I'm going to look here and here and here and here and here. And when it finds it, then great, right? It's going to go ahead and know where that program is so that it can execute it. But we can see here that we went through and we printed all of these. Now, again, these are all sort of backwards. If we were to lay them out with the memory address as the lowest one, so the lowest address of this is the very first letter, right? So these are all the lowest address, and then the address +1, address +2. So I like printing them sort of in a backwards way. So we could have something that would go and print an array in the opposite way. So void print char array uint at. It's just a pointer value. Okay. So now if we want to print that, and we're going to sort of do it in the other way. So, what I wanted to do is I would like to pass in a uint 8_t pointer called buffer. So I can allocate a buffer, make sure it's of the appropriate size. So I'll just do these probably one at a time to test it. I'll probably pick one. But I can take my buffer and let's see how we're going to have to think about this. So I want to print off the 0 thing needs to go. I had laid this out a little bit earlier. I had thought about it. All right. So what I want to do is I want to start at the, see, I need to know how many places this is going to take. Well, let's just do one. So we'll just take the first 8 characters. So we can use string print. Okay, we'll say temp is equal to malloc. We'll do 100 bytes. I don't know how big I want it to be. And then we can say, let's see, sn printf, string with a number, sn printf. Snip intf. Snip printf. Okay. So it takes a character pointer. So this is our buffer. This is how big it is. Then we have a format, and then we have the arguments that would go after that. So this composes a string with the same text that would be printed if format was used in printf, but instead of being printed, the content is stored as a C string in the buffer pointed to by s. All right. So I'm just demoing code here, trying to figure out exactly what I want to do. I have a general idea, but let's look at it. So sn printf. So our buffer is here is temp. The size is 100. I don't want to type that more than once or change it. Okay. My format actually should look something like this. I'm going to print these as uint8t's. But I think, I don't know, we either want 2 or 3 spaces. And I want to print them as hex. So let's just try 1. Oh, it's my Python coming out. %02x. So that'll 0 buffer it. I got a space in front. And this is what I want. So that's 1, 2, 3. You guys can all see I can count. Okay. The tricky part will be, I think we need to print these in reverse order. But we'll get to that. All right, so this would be temp bracket 0. Okay, yeah, we're going to go in reverse order. So the very first thing in this buffer is going to be the thing at number 7. So for int start index equal to, I'm going to start off with 7. Start index is greater than or equal to 0. Start index minus equal 1. So I don't want it. I don't. That would be bad. Okay. And I think snprintf tells you how many. After the format, all right, let's see. I think the result, the int, is the number of characters that would have been written if n had been sufficiently large, not counting null terminators. Okay. So we're going to have to do a couple things. We want to keep track of current size or offset goes 0. Hold on just a second. All right. So this returns how many characters are printed. So current offset plus equals what was printed. Hopefully it gives us a value. Actually, I should keep track of int temp offset equals if temp offset is greater than 0. Again, my Python coming out without my curly brackets. Greater than, or I'll say equal. And then I'll probably not, I don't want to update temp, but uint 8_t pointer current Now we could either add to temp or we could do it here. Temp plus so temp should be a pointer, so it should be an address. Temp plus current offset. All right, so I want to let's see. Here we're just going to do 1. And this is a trick I often use. I'll just set char char dlim is equal to, so that's my prefix. And then so I'm at delimiter. And let's see. So I want to I think I want to do that. I think no. So normally I just reset it and then I add that on to the end. Or I could just, well, so I guess it depends. We want I hate having a first variable. But also I don't want to print a character that doesn't exist. I'm not sure. I mean, I guess I could add an extra space. Put a space at the beginning. Or a space between. So my delimiter is there, and then delim equals a space. Okay. So it'll just add an extra space there. The first one, I'll put it, so we'll have the delimiter. There'll be an extra space. We'll see. Maybe I'll change my mind. Okay, and then I need the end of my for loop. Okay. Okay, let's see. So that should give us our current offset. We calculate that every time. Let's see, I make. Oh, yep. I need my val. Let's see, temp I, and I need delim. All right, so my delimiter is at the beginning, and I guess I need current pointer. Bracket. Start index. Maybe that should be current index. I don't know. What do you guys? I like this theme. This is a Dracula theme. I didn't buy Dracula Pro. I got the free one. We'll have to see. Maybe I like this is a really nice. It's like dark but not too dark. Being queried by my wife. The wife. Making sure I found all the kids. All right. Now let's do a make. All right. So I want to print off. Let's just do an array that we know. So I can just pick one of these that has more than 4 characters. That one has more than 4. Okay. So let's do that one. So we can do print character array EMVP bracket. Let's see. Yep. 23. I'm not actually using buffer, so let's just press in null. Oh, and I didn't print it when I got done. All right. So let's do printf. The string is %s because it's a string. Oh, I need to null terminate it. Wouldn't want to do that. Wouldn't want to forget that. All right. So current offset should have where we are. I think I need to add one. So the temp at current offset +1 is equal to null, a null character. And then I can do temp, and I'm going to put little brackets around it so I know where it is. And new line. And I can actually take off this. That's printing a lot of stuff. Make. Oh, so we only got one. Well, that's no fun. Okay. Current index is 7. Oh, I'm passing in temp. I need to be passing in current pointer. That's definitely wrong. And we're getting all zeros. Oh. Current index. Oh. I don't need to print off current pointer. No. Yeah, I'm not. Oh, why am I pointing to? I need to point. I do need to go to temp. But, oh, I did this wrong. Did this way wrong. Why didn't you guys yell at me? This should be. No, that's right. This should be current pointer. But this should be my value at that location at current index. I don't know how I made that giant mistake. All right, let's do with something I can more easily. I don't remember what was in there. It's fine. Let's do one char array of size 20. demo equals, if I can remember my syntax for string, I think I might be able to say this. A, B, C, D, E, F, G, H, I. I need to pass in demo. That should be a pointer. All right. So A is 61 through 67. Perfect. So it's got at least a. Yeah, I don't like that. I don't like that. It doesn't let me do an empty string. Wonder. C print null character. Print F null character. Let's see. Yeah, I can't print it as a null. I think I'm gonna have to do like a Boolean. Dang it. Does C have bools? First equals C bool. Oh, yeah, it does. Stood bool. Stood bool. Okay. So first is true. If first Oh, and we're gonna have to update buff size. Because we are updating the current pointer, so buff size actually needs to go down. Okay, buff size %C. And I want to print A. Actually, I don't even need to print. I'll just do a bar. I can do that one. Okay. We should probably take this and say here, move it. Temp offset. Of course, it deleted the wrong thing. First is false. Perfect. Now I don't need to lim because so I always have a one that comes before. Maybe we do one after, so I don't need to lim. Okay. Lim not needed. There we go. Well, that was not what I wanted. Oh. Temp offset. Ugh. Forgot to update. Update. Well, then refigures current offset. Oh, I need to increment this. Current pointer plus equal 1. Or I just reassign it. Current pointer is temp plus current offset. I updated current offset. That's okay. I guess it was overwriting. Yeah, current offset must not have been up to date. Okay. So now we got them. They're all centered. That looks nice. I mean, we could do something like putting a tab here. So that way it spaces it off a little bit. All right. So this piece at least does our allocation for whatever our current index is. So then we're going to have to end up keeping track of which, like how many of what we have we need to print and how many we need to print as just null, right? So we're going to have to keep track of, okay, which place are we, right? And we are going to end up almost always starting at, like, the easiest way to do this is starting at the very top, right? So where our null is, if we start there, we can work our way back, or we can, and we can do a variety of different things. We could put this into an array of pointers, and then each one of these allocations only has to happen once. They're of the appropriate size. Not sure how many characters this is. Echo word, pipe it into word count minus C. So that's 43 characters plus null. It's going to give you 44. So that would be one way, and then we wouldn't have to have a giant buffer. But we still have to take care of the edge case of if the length is not right. So we'd have to deal with that. Well, I think we would just have to keep track of our like total size. So we'll have to figure out how long is this, and then figure out what our total size is, and then figure out if that is a multiple of 8. And then for each one of those, we could add them to the buffer. So we could start at the beginning, and then if the current index, so you're going to have like which row, and each row is going to be multiplied by 8. So yeah, I think we got a bunch of work ahead of us to get it to print off in reverse order. And these are all hex. So we might want to put, so maybe actually bigger is 0x. I would prefer that. Then you know. All right, so that actually ends up being longer. A little more verbose, but I think it's also a little easier to read, and you know you're reading hex at that point. It's kind of why what XXD sort of does. So, all right. Well, feel free to comment and like, and if the sound is working this time, so that's a good thing. I checked it before I went, so but all right. Well, thanks guys. I appreciate it. We'll see you guys on the next one. Hopefully I can get some more time to be able to stream a few more times. Anyway,